In this example, we're going to look at the relationship between coronary heart disease, or CHD, and hypertension at baseline in the Framingham cohort to again look at the laws of probability. Shown below, we have a 2x2 table of prevalent hypertension at exam 1 versus prevalent coronary heart disease at exam 1. Using this 2x2 table, we want to calculate the probability that a participant has hypertension or CHD at baseline. So let's define the event H as having hypertension and C as having CHD. And we want to calculate the probability of H or C. We can use the additive law of probability, and we know that this is equal to the probability of H plus the probability of C minus the probability of H and C. Using the table above, we can see that the probability of H is equal to 1430 divided by 4,434. The probability of C is equal to 194, again divided by 4,434, the total population size. And then the probability of H and C is defined by this cell where participants have both CHD and hypertension. And it's going to be 113, again divided by the total population size, 4,434. Doing that calculation on a calculator, we find that the answer to this problem is 0.34. So the probability of having hypertension or CHD at baseline is equal to 0.34. Next, we want to ask the question, are hypertension and CHD independent? And would you expect these events to be independent? So just guessing, knowing what I know about hypertension and CHD, I wouldn't expect them to be independent because generally hypertension is a risk factor for CHD. But let's do the calculations to find out. So for events to be independent, we would then know that the probability of H and C is equal to the probability of H times the probability of C. So we need to see, does that hold in this example? Well, the probability of H and C, we saw before, is equal to 113 divided by 4,434. Plugging in that into a calculator, this is equal to 0.025. We can calculate the probability of H times the probability of C, which is equal to 1,430 divided by 4,434 times 194 over 4,434. Plugging that into a calculator, we find that that is equal to 0.014. And we see that since those two guys are not equal, then the events are not independent. Next, we're going to examine the probability that a participant has CHD at baseline, and then look at the probability that a participant will have CHD at baseline given that he or she has hypertension. So first, we've seen several times in this question that the probability of CHD at baseline is equal to 194 over 4,434, which is equal to 0.025. Now we're going to calculate a conditional probability. We want to look at the probability of C given H. This is the probability of C and H divided by the probability of H, which is 113 over 4,434, divided by the probability of having hypertension. Plugging that into a calculator, we find that the answer to this question is 0.08. So given that you have hypertension, you are more likely to have CHD, as opposed to those where we have no information about their history of hypertension.